Hi class, we are now on 3.5. This is the last section of chapter 4. It's called a preview and I honestly don't know why because I can't find another electron section in the book. So maybe either I'm overlooking it or I don't know why they're calling it that, but that's what they call it. Anyways, let's get started. So we're going to look at electrons, and electrons have, where the focus was in the last section about protons and using them to identify. We're going to focus on electrons, and they are negatively charged particles, and they have a certain behavior to them. And that behavior affects the chemical and physical properties of what we know and understand. So let's do a brief overview of the history of an atom. So John Dalton, Dalton's atomic theory. John Dalton laid the foundation for our modern understanding of atoms. He considered atoms to be indivisible particles, which means that they could not be broken down any further. Then we came to the plum pudding model. J.J. Thomson discovered the electrons, which is a tiny negatively charged particle. His idea that electrons were spread throughout a solid positive matrix, which is, I don't have any idea what plum pudding is. I guess that was popular at the time, but it's similar, your book says, to blueberries spread out in a muffin. That I do know. So then we go on to the Bohr model. We have not covered the Bohr model yet. We will learn it in chapter 4. Bohr model, this is a model that was similar to how a solar system is. This model enables chemists to understand the properties of some elements. However, it didn't cover everything. It did not give a complete picture of electron behavior, because what they found is that some of these models could describe and explain electrons at their particle behavior. But what they also found is that electrons had a wave-like behavior that didn't fit with some of the models that they had in the past. So we came up with the quantum model, and the quantum model explains both behavior of the particles and as waves, and this allows more flexibility in explaining away the behaviors that we've seen. So electron behavior again can be explained as waves and particles. This too should come up in chapter 4, I believe. Okay, so we're going to get into ions. What is an ion? An ion is an atom or group of atoms with an overall charge. How does that happen? Well, atoms gain or lose electrons to form ions. Remember when we discussed neutral atoms had the same number of protons and the same number of electrons. The charges canceled out. We are no longer going to be dealing with just neutral atoms. So why electrons? Electrons are, if you remember, in the electron cloud. They're on the outside. So they have more freedom than what is in the dense nucleus of the protons and the neutrons. Because these are on the outside, they can either get pulled away or get one. So this is a picture. They can either get pulled away. So this is minus an electron. Or it can add an electron, which means this one has 2 now. Excuse me. So when that happens, there's now an imbalance of protons and electrons. That creates a charge with whatever is left over. So that's what we're going to be looking at is ions. So when we refer to ions, that means an atom that has either gained or lost an electron. So let's take a look at lithium here. Lithium is our example. Lithium, it has an atomic number of 3, excuse me, which means it has 3 protons, and it's a neutral atom, so it has 3 electrons. But what if we pulled one of the electrons away? Well, if we did, now we have an imbalance, and that imbalance is going to determine what charge we have with it. So we have 3 protons, but only 2 electrons. That means that 2 of these electrons can cancel out 2 of the protons, but we still have 1 leftover proton, and that will give us a net charge of +1. So here's another way. In reactions to lithium, we haven't really covered this part yet. This is slides from another course, but it gives you an idea of how to determine what charge you're dealing with. So when lithium loses an electron, we have to, this is at the end of the slides, it will show this, but you indicate that by writing the chemical symbol, and the charge that dominates that now ion, you write it in the right hand upper corner superscript. I hope I said that right. So because it has a +1 net charge, we don't write ones, we just write a plus charge. Now this shows that you're dealing with an ion and not a neutral atom. So the charge of the ion depends on how many electrons are gained or lost, and that's what you're going to start showing. So how do we know how to do that? Well, here's a simple formula. You take the ion charge, the number of protons minus the number of electrons, and that's going to tell you what you end up with, and that charge is going to dominate. So basically, if you have more protons than electrons, you're going to have a plus charge. If you have more electrons than neutrons, you're going to have a negative charge. So P plus stands for proton, E minus stands for electrons. For lithium ion, we end up with 3 protons minus 2 electrons, and that gives us a plus charge. So make sure you understand this is plus, this is negative, and that's going to give you that charge. Okay, so this is also not in your book, and some of the terminology and things you see on this page we have not covered yet. That's not important. What I wanted to show you was a visual. I'm a visual learner, so I like to see things that make sense, not just words. So what I wanted to focus on is just this part over here. So sodium atom, so this is a neutral atom. It has 11 protons and 11 electrons. So don't worry about this dot. We haven't covered that yet. But this is the electron cloud. So you can see it's a very big electron cloud. We haven't covered electron configuration yet. All this is coming up. But we are now going to lose an electron. We're going to lose 1 electron from the sodium atom. So when we lose 1 electron, we haven't covered this yet, but it's a visual. You can see that this actually goes down by losing that 1 electron. Now, because we lost the electron, we have an imbalanced number. This is neutral because we have 11 protons, 11 electrons. However, because we lost 1 electron, we now have 11 protons and 10 electrons, which means this is going to have a plus charge. We write a plus on there to show this is a sodium ion because we lost 1 electron. What about if we lose more than 1? Some elements lose more than 1 electron, and magnesium is one that loses 2 electrons. We haven't covered why yet. We will. That's why you actually see these dots here, which we haven't covered yet. But I want you to focus on this. We have 12 protons and 12 electrons. If we lose 2 electrons, you see it actually visually goes smaller too. But we have 12 protons still, but we ended up losing 2 electrons. There's an imbalance here, which creates a positive charge. But not just a positive charge. We have to show the magnitude, meaning the number, to demonstrate that it didn't lose just 1 electron, it lost 2. So now we write it in this corner. It lost 2 electrons. It's got a positive charge, so it's a number first, then the charge. So this is a 2 plus. So it's magnesium ion, and this demonstrates and shows you're dealing with an ion and not, pretend these dots aren't here, and not a neutral atom. Okay, so we're going to go on with fluorine. Some atoms gain or lose electrons. So what about ones that gain electrons? So we just looked at ones that lose. What about gaining? Fluorine is 9 protons and 9 electrons. That means it balances out. It's a neutral charge. What if it gains an electron? Say, what if it gains an electron from lithium? What if this electron came here? We now have 9 protons, but we have 10 electrons. So the negative charge outnumbers the positive charge, and we now have a negative charge to this by 1. So if we look here, we take the fluorine, which is neutral, we add an electron, and now we have to indicate that there's a -1 charge. So we write this in the upper right-hand corner. So it's a superscript. Same rules apply. Ion charge equals number of protons minus number of electrons. And we can write it here. 9 minus 10 equals -1. However, we write the number first, then the charge. If you write the other way, it's wrong. So you can't do the -1. This is 1 plus a negative. So if you see here, we write it with the charge here. But when you write it out, if we go to the previous one, you see the numbers first, then the charge. Okay, so let's take a look at a visual. Again, you haven't covered all this stuff here. For instance, if you notice this says chlorine, now it says chloride. That's because it gained an electron. That changes the name. We haven't covered naming yet. So once we get to all this stuff, you guys can come back to these slides and see if they all make sense then. So we have chlorine. Don't pay attention to the dots. We haven't covered that stuff yet. Look at the visuals. I'm more interested in you looking here. We have 17 protons and 17 electrons. However, it gains 1 electron, this chlorine atom, because it does, you can actually see the electron cloud got bigger. And because it did, now it also shows there's an imbalance. So we have 17 protons and 18 electrons. The negative charges outnumber the positive charges. So we have a negative charge. So ignore all these dots. This would be Cl minus. I will show you. We have more slides. But I wanted to show you that what actually happens, your book's not showing this, and it may not even cover it, but it's a good visual to understand that there's actual changes going on when it gains or loses electrons. Excuse me, atoms lose or gain electrons to form ions. So in chemical reactions, atoms lose or gain electrons. That's how these chemical reactions occur. So when you have a charged particle, a charged atom, they are now ions. They are not neutral atoms. And how you draw in the superscript, a plus or minus, indicates that you're dealing with ions and not neutral atoms. Another terminology, positive ions are called cations. So if you ever hear the term cation, that means you're dealing with a positively charged ion. Negative ions are called anions. Those mean you're dealing only with negatively charged ions. Or you can just go the general standard way of magnesium ion or fluorine ion. The charge of an ion is shown in the upper right hand corner of the symbol. Ions charges are usually written with the magnitude first. That means the number and then the sign of the charge. So for instance, magnesium is written with the 2 plus, and oxygen is written with the 2 minus. This means that magnesium lost 2 electrons and oxygen gained 2 electrons. And if you get confused about, look at the charges here and understand the number of protons minus the number of electrons. And there's another one here, and hopefully this makes sense to that. And if not, look at the pictures. Look at the balance, the numbers, and that will remind you of why something has a charge to it. That's why I put these up here, so you can actually look at visually what's happening. Okay, so let's take a look at something. Write the formula and symbol of an ion with 16 protons and 18 electrons. This is not difficult. We can see one that first thing's off. You're dealing with 16 protons. You are not dealing with 16 electrons, so this is an imbalance. You are dealing with an ion. Now we have to figure out what element it is. So 16 protons, that's the address, so atomic number. We can look here, and we see it's sulfur. So with sulfur, we can see that it should, excuse me. So if we're dealing with 16 protons minus 18 electrons, so let's take a look. Remember that here, ion charge. Protons are first, electrons are last. So if we do 16 minus 18, that gives us, let's go over here, to a -2 charge or 2 minus charge, because we now have more electrons than protons. So if we have to write this out, we can see that it's sulfur, and we write a 2 minus in the corner. That indicates that it has 2 extra electrons, and it is sulfur. And it's negatively charged. Okay, so this is another one. This is interesting because these ones that look a little different, these are from my other course. This one's from this course. And I wanted to cover mine first, even though this is the same exact problem. So sulfur is an atomic number of 16. Sulfur atoms commonly form sulfide ions, which have a -2 charge. How many electrons are in the electron cloud of a sulfide ion? I don't like the way they asked this. That's why I chose to do mine first. I don't know why. I think mine was a little bit more simpler to explain, but I could be wrong, and you could disagree with me. Okay, so first things, sulfur has an atomic number of 16. We know that a neutral atom has 16 protons and 16 electrons. By the way, I do like how they broke this bottom part up, which is why I wanted to do mine first, and if that didn't make sense, hopefully this does. But it now has a -2 charge. So because it has a -2 charge, that's the problem here, is that do you subtract or do you add? Now, electrons are negative. So that means, it means the opposite in the chemistry. If it has a negative charge, it means it gained electrons, didn't lose them. If you have a positive, it means it lost those. And this is where understanding this formula might make life a lot easier. If you know number of protons minus number of electrons. This is not in your book. This is from another book. That's why I'm putting this up there. Because something like this question is confusing. But if you understand that it's telling you you have 16 protons That means a neutral one would have 16 electrons, but you now have an extra charge of 2. That means you gain 2 electrons, which means you have 18 electrons. That's why you have negative 2, that's why you have negative 2 for the charge. It means you have 18 electrons and 16 protons. Let's say that still didn't make sense. Plug it in. Represent this. You know, you can isolate some of this stuff away. You have 16 negative x with a 2 minus. Try solving for the x. Move things around and see if that works for you. And I think that will. And it will. Because I just wrote it out. I paused it and wrote out. So if you put 16 here minus x equals negative 2, it will give you the number of electrons. So 16 minus x, negative 2. Move the x over this way. Move the negative 2 to plus 2. So this would be 16 plus 2 equals 18. That means x is 18. That you have 18 electrons. I hope that makes sense. If it doesn't, you can always email me. But again, that's just algebra. So, but this is a perfect example. Sorry, I was coughing. I had to pause. This is a perfect example of a chemistry question that is something a little difficult to read, but the how to break it down, if you have the skills and the patience to learn what it's actually asking, this problem is not a difficult problem. It's no more difficult than this problem here, the one that I put up. You just have to learn how to translate what's being asked. And yes, you'll probably get more questions like this than like this. But if you have the knowledge already, you just have to take the time and patience to break down what exactly is being asked. And I'm giving you some, you know, like here, like the formula, and that should help you if you need to use it. Okay, consider the elements of calcium and chlorine. Write the symbol, including its ionic charge and the name of each resulting ion. So we haven't really covered naming, so one of these is not going to be, we'll cover it. I'll briefly go over it. Calcium loses 2 electrons and chlorine will gain 1. So that's giving you enough information for you to be able to determine what's going on. Look at a periodic table. It's going to give you everything you need. So let's look at calcium first. Calcium has an atomic number of 20, but it loses 2 electrons. So 20 minus 2 equals 18. So we have 18 electrons, but 20, excuse me, I probably should have put protons here. I should have made this match the formula, and I didn't. I wasn't thinking about it. Anyways, you end up with 18 electrons, but you have 20 protons. That means that you have a positive charge. And because you have a positive charge, you need to indicate that you have a positive charge of 2. So here is calcium. You write a 2 plus in the corner, and that's telling you it's a calcium ion. And you can write out calcium ion. With chlorine, we have to start out with 17 protons and we gain 1 electron. That means that you have more electrons than you do protons. So you end up with a negative 1 charge. So with the negative 1 charge, we never write the 1 out. We just put the negative sign, which implies 1. So it's Cl, and you can see Cl is here. So if you had to look at what the chemical symbol was. And the negative is a superscript in the corner. Now, we haven't covered naming, so you wouldn't know this chloride ion portion, and that's fine. As long as you understand these 2 parts and how to get to them, that's the important thing.